Folks, welcome to our final. How many weeks of regular classes do we have? 3 weeks. Only 11 regular school days, yes? Because the Friday of the final week, this quarter only has 8 weeks and then exam week. But the final week, that Friday, you'll have your first exam slated to begin. Exam would be which period on that Friday? 10th period. Then we would have Memorial Day off. And then we will begin exam week. Our exam in here is what day? First and second period. Isn't that on Tuesday? Is that how it goes? First and second Tuesday. Then is it third and fourth Wednesday, and then 5/6/7/9 or whatever on that Thursday. And then you'll have no exams that Friday. I believe we come in Wednesday of exam week. So, with that said, everybody is entitled to how many exemptions? 1. Everyone gets at least 1. If you have all A's, how many total do you get? 3. If you have all A's and B's, how many total do you get? 2. If you have C's, D's, you at least get 1. Now, you cannot exempt an exam if you have what grade in that class? Either 9 weeks. If you have a failing grade, either the third or the fourth quarter, you have to take that exam. That's just the way it is. So as you begin thinking about whether you should exempt this exam, I would ask myself a couple questions. How have I done the third quarter and the fourth quarter in chemistry? A lot of you have gotten all your homework turned in. You have solid A's the third and fourth quarter. If I had solid A's the third and fourth quarter, I would probably not exempt that one. So like if you have like a 100% in here both quarters, I would not be afraid to take that exam, especially if you've done your homework. If you've completed your homework and you're like, well, I did my homework. How else would I have gotten a solid A in your class if I didn't do your homework? There's a difference between doing the homework and understanding the homework. So if you've done your homework, that's great. If you understand the homework, I would not be afraid of the chem exam. Not at all. Not at all. If you know what's going on in the class, don't be afraid of the exam. It's not going to be impossible. If you've completed your homework, maybe just completed it. Maybe you have not been dialed in during this pandemic to trying to do all the things that you've been asked to do on your own, a lot of this, and you have an exemption. If you've been not really trying on the homework, just making it look like you've gotten it done, I would tend to use an exemption on a chem exam so that you don't mess up your grade. I would hate to see you have a decent grade and then lose it on exams. That's just what I would be afraid of. So as you're thinking about how many exemptions you have, don't fear the chemistry exam if the stuff we've been doing doesn't seem to be a big problem to you. Speaking of what we're doing, we began our final unit last week, Unit 9. It is great that we're getting to have a chance to get through Unit 9. It may be one of the most important units that we do. It is a very, very important unit. If you remember last week, we had a chart that looked something like this one. We started off looking at a chart something like this one last week. I think on the chart we looked at last week, mass was over here, quantity count was down there. I think we had mass and quantity count. But the big thing we wanted to do last week, now it doesn't really matter here where everything is on this particular chart. But the big thing we learned last week is there is something out this way. We know we have something here. Moles can be converted to volume. Moles can be converted to quantity count. Moles can be converted to mass. But it seemed like we were missing something over here. Looking at this chart, we were sort of off balance. We could go north. We could go west. We could go south. There was no land to the east. But now there is. What is the land to the east, we learned? We can go to moles. We can convert moles of one thing to moles of something else. All we need is a what? What is it that you can convert moles of one thing to moles of something else? What is that thing that relates moles to moles? It is our balanced chemical equation. Balanced chemical equations. The coefficients relate moles to moles. So to go from mole to volume, we need the molar volume, 22.4 liters. Mole to quantity count, we need Avogadro's number. Mole to mass, you need the periodic table. But now we can go mole of one thing to mole of something else. But if you can go to mole of something else, shouldn't you be able to convert it to a volume of something else? Absolutely. Couldn't we convert it to a mass of something else? Or even a quantity count of something else, provided we can go from mole to mole? The answer is absolutely. When we went east, it opened up a whole new ability to convert moles of one thing to moles of another, and then we could certainly find out anything else. And if you look at it, once we go to moles, we can go up to volume, we can go over to quantity count, we can go down to mass, but I think we're going to flip the mass into quantity count here. So we have an arrow going up here. We really don't need this arrow going up here. The arrow right there that goes up, we really don't need that arrow anymore. We have an arrow going that way, so we really don't need an arrow going that way. We just need this one. We have an arrow going down, so we really don't need that arrow going down. In fact, all we really need is volume to moles. We need an arrow that goes from volume to moles. We need an arrow that goes from volume to moles. We need an arrow that goes from quantity count to moles. We need an arrow that goes from mass to moles. Where's our arrow going from mole to volume? Right there. Where's our arrow going from mole to quantity or to mass in this case? Right there. Where's our arrow going from moles over to quantity count? It's right there. So we have the arrows going all directions. You see how this chart has been just manipulated a little bit. And from this chart, we have our new working chart. Here it is. A new working chart. This is the same thing that we had before. It just has moles and moles right there. There's our volumes. There's our masses. As I said, we're putting the masses off to the side. And there's the quantity counts going down. This has everything we need to do the types of calculations we will be doing in Unit 9. There is a whole unit in chemistry called stoichiometry. Stoichiometry merely means that you are using a balanced chemical equation in your calculations. Stoichiometry is all about taking one thing that you know about a substance in a chemical equation and finding out something else about another thing in the chemical equation. So if you know the volume, the moles, the mass, or the quantity count of something in a chemical equation, you can find the moles, the mass, the quantity count, and the volume of something else in the chemical equation. All you need is the chemical equation. That is what we do in stoichiometry. That is all we do. Last week we spent 2 days we spent 1 day really learning to do the mole to mole using the chemical equations. Then on Friday, we got to see plenty of practice problems where they converted mass of one thing to mass of another thing. And I'm going to stand before you today and say, If you learn anything in Chem 1, know how to do what's called a mass-to-mass calculation. That is one of the most fundamental and most important calculations in this entire subject of chemistry. When you have the mass of something in a chemical equation, a question that is always going to be an important one is, what are the other masses involved? So if you know a certain mass, you have a certain mass of a product that you want to make, you can find the mass of the reactants you need to make that product. That's what chemical engineers do. There's an area of engineering called chemical engineering. What do chemical engineers do? They work in industry. Anything that makes chemicals needs chemical engineers. What do chemical engineers do? They're like, okay, salespeople, how many kilograms of our product have you sold? Oh my gosh, I need to make that product so that you can sell it. So I need to know how much mass of everything I need to make that product. They do not do this happen chance. If you're making something and you want to make 2 grams of it, you would not want to be wasteful in the number of grams of the reactants you use to produce it. If you're going to make 2 grams of a product, you're not going to want to put in 4 grams of reactants. Why? Mass in equals mass out. You're going to be wasting tremendous amounts of substances. What do chemical engineers do? They make it so that they put in just the amount of reactants they need to make the product that they're trying to make. And they want to make it so that the reaction conditions are going to yield the best product. What temperature do we need to make it at? What pressure does it need to be at? So that we can maximize our yield. This is why, of all the engineering majors in college, one of the highest paid engineering majors is chemical engineering. It is one of the highest paid engineering. If you like math and you like chemistry, there is jobs that pay big bucks. Because industry will hire you so that you are not wasting their money on the reactants. It is unbelievable. They start out right up with some of the highest paid engineering positions. If you don't believe me, Google highest paid engineering majors. They will be up there. You're like, do they make as much as computer engineers? They certainly can. They certainly can. Do they make as much as electrical engineers? They certainly can. If you do well in this, there are tons and tons of jobs. So, our calculation we're focusing on, mass to mass. How does a mass to mass calculation work? Let's take a look. Mass to mass, what are we doing in this type of calculation? Here's an example problem. Have you ever wondered how they keep astronauts in the space station? From having to breathe in their exhaled carbon dioxide. They're like, if you're in a space station and you're just floating around in the space station, how do they get oxygen to you? And how do they get rid of the carbon dioxide so that they do not suffocate? Every time they exhale, they're putting carbon dioxide into the space station. This is kind of a time topic. Space stations have been in the news very recently. So how do they get rid of the carbon dioxide? The answer, one way they could do it is using lithium hydroxide. Because lithium hydroxide will react with carbon dioxide and you produce a salt, lithium carbonate, and water. Engineers at NASA And now all the different companies that are involved in space exploration might want to know something like this. How many grams of carbon dioxide could you actually get rid of for every 100 grams of lithium hydroxide that you send up into the space station? How many grams of lithium? So our question we would have, how many grams? Our question, how many grams of carbon dioxide could we get rid of? Could be absorbed by our given 100 grams of lithium hydroxide. Can you see that this is a mass-to-mass problem? We look back at this chart right here. What did they give us? 100 grams of lithium hydroxide. What are they asking for? How many grams of CO2 could we get rid of? Do you see the problem? How many steps would this problem take? If I'm picturing the setup of this problem, I'm given a mass and I'm asked for a mass. How many conversions is this problem going to have? First, I have to go from mass to moles. There's one setup, yes? My very first setup, I have to go from mass to moles. Then I'm going to use the equation. There's an arrow. I'm going to need a second part in the middle, mole to mole, and then I'm going from mole to mass. Do you see the three setups? You will have a chart like this. These tests are merely reading tests. How many grams of CO2 can I get rid of from 100 grams of lithium hydroxide? So here's my given. Here's my first setup, second setup, third setup. What's my first setup? My given. There's my given. The given always goes first. Yes? My first setup is moles of what I'm given over grams of what I'm given. Moles over grams. You're like, where did you get that? Right here. Moles over grams. Moles over grams from the periodic table. Moles over grams from the periodic table. My second setup says right here, mole coefficient from the mole of what I'm trying to find is on top. So moles of what I'm trying to find is on top. Moles of what I'm given is on the bottom. The given side here is in red. Where I'm going to is in green. So moles of what I'm trying to find on top. Moles of what I'm given is on the bottom. Take a look here. Moles of what I'm trying to find is on top. CO2. Moles of what I'm given is on the bottom. Then finally, my last step, grams of what I'm trying to find on top, moles on the bottom. Grams of what I'm trying to find from the periodic table, moles on the bottom. The three setups. Yes? They're right there. Now, where do I get the numbers for all of this? Where do I get the numbers? Well, it looks like we're not going to be able to erase quickly, so we will erase old school. Where do I get the numbers? The first part of this calculation. The first part of this calculation, I need the 1 mole of lithium hydroxide. This is what I need. I need moles of lithium hydroxide. That's what I'm given over grams from the periodic table. So the first thing that I have to do is add up the molar mass of lithium hydroxide. We know how to do that. Lithium hydroxide has 1 mole of lithium in it at 694. It has 1 mole of oxygen in it at 16. It has 1 mole of hydrogen at 1. Add those up. The molar mass of lithium hydroxide, 1 mole of lithium hydroxide is 23.948. I can write that two ways. I can put mole on top, mass on the bottom, or I can put mass on top, moles on the bottom. Which one do I need? Well, my given is 100 grams. So I need the one with the mass on the bottom, so that mass cancels out. So this is the one I'm needing. I'm going from moles to mass. I need mole on top, mass on the bottom. You're like, how did you know to pick that one? Right over here. I need mole on top, mass on the bottom. Mole on top, mass on the bottom. I hope you're watching this because there is an exam question, I promise, on this. I promise. One of our exam questions, you'll have a full page of a problem, mass to mass. So be sure you're watching this carefully. Are we okay where I get this expression? Now I need to put coefficient from the equation of what I'm converting to on top, coefficient from the equation of what I'm given on the bottom. That's my middle conversion. Here we go. Here's my middle conversion. I'm trying to find moles of CO2. It's on top. Moles of lithium hydroxide is on the bottom. Where do I get these numbers from? The coefficients of the balanced chemical equation. Where's my balanced chemical equation? Right here. It's 2 moles of lithium hydroxide are needed for every 1 mole of CO2. It's 2 moles of lithium hydroxide for every 1 mole of CO2. I write that 2 ways. That's an equality can be written 2 ways. I can put moles of lithium hydroxide on the top, 1 mole of CO2 on the bottom, or flip it. I can put the 2 moles of lithium hydroxide on the bottom and the 1 mole of CO2 on the top. Which of these 2 am I going to select? I'm going to select this one right here because moles of what I'm converting to goes on top. How do I know? Well, I have mole of lithium hydroxide there. I have mole of lithium hydroxide there. These can now cancel out. Grams cancel out. Moles of lithium hydroxide cancel out. My unit is now moles of CO2, and I'm on my 3rd and final step. We said this problem would take 3 steps. Here's the 3rd step. I need grams from the periodic table over moles. I need grams over moles. Here we go. I need grams over moles. Where do these numbers come from? I don't know. Where do I get these numbers from? The periodic table of elements. I'm going to add up the molar mass. I will add up the molar mass. That's what I'm going to do. How do I do this for CO2? Well, there is 1 carbon at 12. There's 2 oxygens at 16 each for a total of 32. 2 oxygens at a total of 16 each for 32. 1 mole of carbon at 12 for 12. 12 and 32 is 44. I can write this 2 ways. Mole on top, grams on the bottom, or I can put grams on top, moles on the bottom. This is my equality. Equality gives rise to 2 conversion factors. I need this one right here. I need grams on top. Take a look at what happens to the units then. Grams of lithium hydroxide cancel. Moles of lithium hydroxide cancel. Moles of CO2 cancel. I'm left with grams of CO2. That's what I'm trying to find. Problem's done. That is all we have to do in these problems. A mass-to-mass problem is going to take 3 setups. Every time, it'll take 3 setups. Carefully look. If you do this correctly, you will always have 3 setups. What are we looking for? Right here. My question, always go first. I'm finding grams of CO2. My given is right here. 100 grams of CO2. How many grams of 100 grams of LiOH, lithium hydroxide? The question is, how many grams of carbon dioxide will be absorbed by 100 grams of lithium hydroxide? Given goes there. First conversion, mole over grams. Second, mole to mole. Third, grams, mole to mole. Notice, the only time you will have a number other than 1 possibly next to moles is in this part. Notice there's always a 1 here, always a 1 there. These problems will be set up like this every time. Every time. Every time you're going to have mole over gram, mole over mole, gram over mole, and there will always be 1s there. These numbers come from the chemical equation. These numbers come from the periodic table. Every time. If you learn to do this and you get comfortable with the system, you'll be in great shape. You'll be in great shape. Today we have practice problems 9-4 to do. Listen carefully. Listen carefully. I did not put the answer key up for this problem. The answer key for 9-4 will not go up till tomorrow morning around 7 a.m. If your homework is not submitted, are you listening? If your homework is not submitted by 7 a.m. completed, you will not get your points for it. You will not earn full points. This is an important problem to do. It's an important problem to practice. We have 4 practice problems. I'm not putting the key up because I don't want to tempt you as you're learning to do these to just copy numbers straight from the key. I've had students copying and pasting answers right from the key onto their homework. Wow. There are help videos to watch if you're having trouble. So you're like, but I need the answer key to see if I'm doing these right. No, there are help videos posted that you can watch to be sure you're doing it right. Homework needs to be in by 7 a.m. tomorrow morning. Don't mess this up. Learn to practice. This is an essential problem. Good luck.